Hello, my little mathematicians. Today we are going to review everything we learned from the expressions unit. So things like all the different properties, the different parts that make up an expression, and the order of operations, as well as the difference between an expression and an equation. So let's jump right in. Okay. The identity property is, think of something like it doesn't want to lose its sense of self. Okay, so whatever it started as is how it wants to end. So if you started as 8 and you want to multiply by something, what could you multiply 8 by and still stay 8? You can multiply it by 1, right? 8 times 1 is still 8. So 8 is equivalent to 8 times 1, and that's an example of the identity property. Okay, what about if you were adding? What could you add to 8 and still have it remain 8 if you added 0? Okay, so that's an identity property. If you add 0 or multiply by 1, it still keeps its sense of self. Okay, for the commutative property, the commutative property is where numbers actually move. So think of it like a commuter train. You know, a commuter train moves places. So if you started as 6 times 3 times 2, 6 times 3 is 18. 18 times 2 is 36, right? So as long as I still have 36 on this side, it'll still be an equivalent expression. And I want it to be the same numbers. It's just they can move places. So notice how the 6 and the 3 are still being multiplied. 6 times 3 is 18, and 18 times 2 is still 36. But instead of the 2 being at the end, now the 2 is at the beginning. Okay, so they moved places. That's the commutative property. The associative property, think of like business associates, okay? So your business associate is within your group at the building, and it's like who you hang out with. So the grouping changes, or who you're associating with changes. Okay, so here we still had 6 times 3 times 2. Okay, that's how it started. Now for it to be the associative property, let's say that, 6's mom was like, or 3's mom was like, you know what, 3, I don't want you hanging out with 6 anymore. They're a bad influence on you. You should hang out with 2. So then 3's like, okay, sorry, 6, I can't hang out with you anymore. I'm going to hang out with 2 instead. Okay, so now 3 is hanging out or associating with 2 instead of previously it was grouped together and hanging out with 6. So who 3 was associating with changed. That's the associative property. And then finally, the distributive property. Okay, the easiest way to see it is, let's put a variable in there. So let's say we have 8 times x plus 7. Okay, so if I want to distribute that 8 to everything inside the parentheses, so then I would go 8 times x is 8x plus 8 times 7. Well, what is 8 times 7? 56. So 8x plus 56 is the same thing as 8 times the x plus 7. I distributed the 8 to everything inside of the parentheses. Okay? And then the one other thing that we need to remember from that section is the word reciprocal. Okay, say it with me, reciprocal. A reciprocal, the fancy term, is the reciprocal of a number results in a product of 1, meaning when you multiply a number times the reciprocal of itself, you end up getting 1. Well, let's test that, okay? So if we started with 5, 6, and I multiplied it by its reciprocal, that means what was on the bottom goes up to the top, and what was on top goes down to the bottom. So 6/5 is the reciprocal of 5, 6. Well, let's see what happens when I multiply those. These cross cancel and become 1, and the 5's cross cancel and become 1. And then you have 1 times 1 is 1, 1 times 1 is 1, 1 over 1 is 1. Oh, hey, yep, that's true. The reciprocal of another number multiplied by itself is, a number multiplied by its reciprocal results in the product of 1. Okay, let's break apart this expression into all the different vocab that makes it up, okay? So first off, we have all the individual terms. So you have this term right here of 4x, that term of 7 squared, and that term of 10. Think of it as everything that's separated by a plus or minus sign. That's what makes up all the different terms. Okay, your variable is any letter that's used to represent an unknown number. Okay, so there we go, the x. The coefficient is the number in front of a variable. So what would that be? Hopefully you said the 4 would be the coefficient. Okay, what's the exponent for that one? Exponent is that little number up there that's attached to either a number or a variable. So in this case, the exponent was a 2. Okay, a constant is anything that doesn't have a variable, because if it has a variable, this term can change. Because if it's 1, well, 1 times 4 is 4. But if it's 2, 2 times 4 is 8. If it's 3, 3 times 4 is 12. See how this term changes depending upon what I plugged in for x? But this term, there is no variable, so it'll stay a constant. It'll always be 7 squared, or 49. This term doesn't have a variable, so it'll always stay 10. So my two constants for this problem would be -10 and 7 squared. It's the number by itself that has no variable attached. Okay, and then an operation sign is the signs that separate your terms. So in this case, there was a plus and a minus sign. Okay, and there you go. That's the different parts that make up that expression. Okay, now what's the difference between an expression and an equation? Well, let's write out, like, you know how they used to give us word phrases and then we had to translate it into an expression or equation? So if it said the difference between a number and 12. Okay, well, what does difference mean? Difference means minus, and you put it in the order it comes. Between some number we don't know and 12. Okay, notice that an expression doesn't have an equal sign, which is different than an equation. An equation does have an equal sign. So if they gave me a word phrase, like, let's have it almost be similar to this. So we would say the difference between a number and 12, the only difference would be, now we'd say is, let's say 4. Okay, so that means that this is means there's an equal sign. So it's almost the same. Difference means minus, a number, and 12. But the is means equals. And what does it equal? 4. So that's the only thing that changed it from an expression into an equation, is that we had an equal sign. Is in the math world means equals. Okay. So for this one, we would try to get x by itself. So what's preventing x from being by itself? This -12. The opposite of -12 is +12. So that those cancel, because 12 minus 12 is 0. X plus 0 is just x. Woohoo, we got x by itself. But whatever you do to one side, you got to do to the other. So 12 plus 4 is 16. So here, this would be x equals 16. For this side, I can't do anything like that because there isn't another side of the equation to do the same thing to. Because remember, I could add 12 as long as I did the same thing to the other side. So expressions just stopped. That's all you can do. But for this one, I can solve it by doing the inverse step, right? The inverse of -12 is to add 12. And then I isolated x and solve for it. The only way I could simplify this anymore is if they told me something to plug in for x. All right, the last thing we're going to review is the order of operations, sometimes referred to as PEMDAS or GEMDAS. Same thing, parentheses or grouping symbols. And then exponents, multiplication and division, addition and subtraction. This is the order in which you should do things. Notice that there's an arrow between M and D and A and S, meaning you should always multiply or divide before you add or subtract. But when deciding between multiplying and dividing, you do whatever comes first from left to right. Okay, and again, you do multiply dividing before adding and subtracting, but when deciding between adding and subtracting, you do whatever comes first from left to right. Okay, so if we take a look at this, parentheses, no. Exponents, yes. 6 squared is 36. So bring everything else down. Okay, parentheses gone, exponents gone. Multiplication or division, yes. Now the trap is to do the multiplication first. But remember, we said when deciding between multiplying and dividing, you do whatever comes first from left to right. So 9 divided by 3 is 3. Bring down your times 4. Okay, and then parentheses are gone. Exponents are gone. Still see some multiplication or division. 3 times 4 is 12. Bring the others down. 36 minus 12 is 24. And please don't be ashamed to actually do that math off to the side so that you don't make a simple error. I don't know why I borrowed. I was rushing. 6 minus 2 is 4. 3 minus 1 is 2. And you get 24. Okay. Last one. Again, if you haven't tried something yourself, go ahead and try this one before we do it. Okay, you paused it. Now you unpaused it. You're back with us. Parentheses, yes. Do that first. 8 divided by 2 is 4. Bring everything else down. Okay, parentheses, when I say parentheses, that means parentheses, things within them are simplified down to a single number. Yes. Okay, there are no exponents. And then multiplication or division. Because there's a number touching this parentheses right here with no sign between it, that means that those are being multiplied. Okay, again, when there's no when there's no sign between a number and a parentheses, that means that those two numbers are being multiplied. Okay, so 6 times 4 is 24. Bring down your minus 5 plus 14. And now you only have addition or subtraction, so go from left to right. Okay, so you have 14 plus 24. You get 38 minus 5. Don't rush like I did last time. Don't get cocky. Do it slow. Slow and steady wins the race. It's not a race, right? So take your time. Go slow so you don't make mistakes. 38 minus 5 is 33. And there you go. All right. Congratulations, my little mathematicians. You have now just reviewed all of expressions.